This is number 6 from the 2014 AB exam, a question on differential equations. And it tells us to consider the differential equation dy dx equals quantity 3 minus y times the cosine of x. And we are first asked to sketch the solution curve given the slope field of this differential equation. We want to do so through the point 0, 1. So we can first begin by labeling the point on the graph. And then all we need to do is follow the slopes that we've already been given. The slopes increase on the positive side of the x-axis, they level out, and then they decrease again. And on the negative side of the x-axis, they increase, levels out to 0, they decrease in the beginning. So we can connect all of these to make our solution curve. So this should be a pretty easy process because we've already been given all of the slopes. Those little lines indicate the slopes at those points. Now, parts B and C have to do with working with the actual differential equation itself. So part B tells us to write an equation for the line tangent to the solution curve at the point 0, 1. And then we have to use the tangent line equation that we write to approximate f of 0.2, where f of x is equal to y, which is the solution to the differential equation. Typically, tangent lines are written in point slope form, but since we need to do an approximation, we want it in slope intercept form, so that it's just easier to plug in x. We can first put the line into point slope form so that it's easier for us to see what we need and what we already have. Point slope form is y minus y1 equals m, the slope, times x minus x1 for point x1, y1. We already have the point 0, 1. We can just solve for the slope by plugging this point into the differential equation. So the slope would be equal to dy dx at the point 0, 1, which we have the equation. The equation is just 3 minus y times cosine of x. So we can say 3 minus 1 times cosine of 0, which is 2 cosine of 0, which is just 2 times 1, which is just 2. So now we can plug all of these numbers into our point slope form. We'll get y minus 1 equals 2 times quantity x minus 0, which we can just simplify and turn into slope intercept form, which would be y equals 2x plus 1. So this is our tangent line at the point 0, 1. But we're not done just yet. We need to approximate f of 0.2 using this equation. Plug in 0.2 for x. So y equals 2 times 0.2 plus 1, which is just 1.4. This is actually equal to y of 0.2, which is approximately f of 0.2. So this is our tangent line approximation. And this is our actual. So we can't equate them because they're not quite equal to each other, but we can use the slope at the point to basically estimate a value on the solution curve, the idea of linear approximation. Our answer here is 1.4. Now the final part of the problem asks us to actually find the particular solution to the differential equation with the initial condition f of 0 equals 1. So here we'll have to integrate both sides by the separation of variables method. So our initial differential equation is dy dx equals 3 minus y times cosine of x. Now we want each variable on their own side. So we want to separate x and y. So we can multiply dx over and divide by 3 minus y to get dy over 3 minus y equals cosine x dx, basically cross multiplying. Now if we integrate both sides, so now we can do a quick u substitution on the left hand side. If we let u equal 3 minus y, du will equal negative 1 dy, which is our numerator. But our numerator is actually positive dy, so that'll actually equal negative du. So we can use this substitution to make it easier for us to integrate. So we'll get negative du over u equals integral of cosine x dx. This will just be negative ln of absolute value of u equaling sine x plus c. And now we have to plug u back in. So we have negative ln of 3 minus y equaling sine x plus c. Now, it is of paramount importance that you double check this step because solving for the constant of integration will depend on you integrating the equation correctly. And in addition, do not forget the plus c because without the constant of integration, you can only earn a maximum of 3 points. In order to solve for c, we can use our initial condition that f of 0 equals 1. We can plug the point 0, 1 essentially into our equation. So we know that negative ln of 3 minus 1, because y is 1 here, equals the sine of 0, or x, plus c. Sine of 0 is just 0, so this is equal to c. Now this means that negative ln of 2 is equal to c. So now we can plug c back into our original equation to get negative ln of absolute value 3 minus y equals sine of x minus ln 2. Now, we want to get rid of the ln because we want y to be alone to make this an explicit relation. But the left-hand side is negative. So to make it easier for us to work with this equation, we can divide both sides by negative 1. And doing that, we'll get ln of, now positive ln of absolute value 3 minus y equals negative sine x plus ln 2. So reversing all of the signs. So now we can raise both sides as exponents to the base of e to rid the equation of natural log. And now we'll get absolute value of 3 minus y equaling e to the negative sine of x plus ln 2. The addition of exponents equals the multiplication of the bases. This equals e to the negative sine x times e to the ln of 2. Now, this cancels, so we're just left with 2 in the front. Now, to get rid of this absolute value, we can add a plus or minus to the right-hand side. Sine x. This is because the absolute value implies that no matter what the sign of the actual right-hand side is, the function will always be positive. So we can undo this by reversing that. Since the left-hand side is always positive after the absolute value, the right-hand side can either be negative or positive. We can just add y to both sides and subtract the right-hand side from both sides. So the sign now doesn't matter because we're both adding and subtracting at once. So we've just isolated y and made it positive. So now we have to choose signs, and the best way to do this here, because this one is, it has trigonometry, so it's a little bit more tricky, the best way to do it is to just plug in points. So we already know from our initial condition that f of 0 equals 1. So if we had 3 plus 2e to the negative sine of 0, well, sine of 0 is always 0, and e to the 0 is 1. So this would equal 3 times 2 to the 1, which is 5, which is not 1. If we choose the minus sign, we will get 3 minus 2, which is 1. So we need to choose the minus sign. So our actual y, the particular solution, will be 3 minus 2 e to the negative sine x. And always plug in these points just to double check that you've done everything correctly. So even if you have no idea where to start, always begin by separating your variables. That will at least earn you 1 point. And for further problems, see 2006 AB number 5, 2006 Form B number 5, and the Stewart textbook, section 9.3, numbers 27 and 28. Thank you.